Okay, hello guys, welcome to today's session. Today we'll be going through the November 2018 Higher Paper 1. We're going to be carrying on from where we left off last time. So we've already done half the paper approximately, just a bit less than half, so we've done all these before. Today we're going to be starting from question number 12. Okay, so let's get started straight away. This question here, we want to work out the angle inside, one of the angles inside this circle. So we're told that A, B and C are points on the circumference of the circle, center O. DAE is the tangent to the circle A, at point A. We're given two angles here. We know that BAE is 56 degrees and CBO is 35 degrees. We want to work out the size of angle CAO. So first of all we need to understand which angle we're working out, and it's this one here. This is the angle that we need to find, angle CAO. Work out that angle. You must show all your working. Okay, so straight away we can see this angle here is 56 degrees. So therefore, using the alternate angle theorem, which is this one here, we know this is also going to be 56 degrees. Now if you can't spot that, if you didn't spot that's also going to be 56 degrees. Now there's another way you could have also got that as well. It requires a couple of more steps, but I'll show you anyway. But for the time being, let's write down the first thing. I'll show my working here. So we know that angle ACB, angle ACB is 56 degrees. Okay, we're going to give a reason for our answer as well, because of the alternate angle theorem. Okay, it's an alternate angle theorem. Now, as I said, if you didn't spot that alternate angle theorem, another way you could have got that is as follows. Angle BAO. Okay, what's angle BAO? BAO, this one here. Okay, what can you tell me about this angle? Notice this is a tangent where it meets the radius. So that circle theorem, that any angle, any tangent that meets the radius is a right angle. So therefore, this angle here, BAO, has to add up to 90. We know that's 56, so therefore this is going to be 34 degrees. 34 degrees. Next, yeah, adds up to 90, correct. After this, we can work out the angle ABO as well. Notice, because these are two radii, this is a radius here, and this is a radius here. So therefore, this forms a triangle, isn't it? What kind of triangle is this, where we have two sides that are the same? Triangle with two sides that are the same is an isosceles triangle. Okay, and therefore the angles at the base are the same. So this is also going to be 34 degrees. Okay, yeah. Okay, now why is that important? Well, now we can work out angle AOB as well. We can work out this angle here, because angles in a triangle add up to 180. So if you know that's 34, that's 34, that's 68. Therefore this angle in the center is 112. And now the other circle theorem, the angle at the center is twice the angle at the circumference. So therefore we could also work out this angle here, ACB, that way as well, because half of 112 is 56. Now I showed you this as a alternate method of working out the angle 56, but the best and easiest, quickest way is spotting that it's an alternate segment theorem, and that therefore it's the same with that 56. But even if you didn't know that, there's another way you could have got that. Now that's just the first part. That's not the angle we want. We want this angle here, isn't it? Angle CAO. Now, so we've got this angle 56 degrees. Now we can work out the angle of OCB. Now if I was to put another radius here, then again this length is the same as this length here. So this angle, if that's 35 degrees, then this angle is also 35 degrees. And so what's left for this angle here? So we know that's 56. The full angle is 56. Okay, if that's 35, then angle OCA is going to be 21 degrees. And because this is, again, these two lengths are the same, it forms another isosceles triangle. Therefore, if this angle is 21 degrees, then angle CAO is also 21 degrees because it's an isosceles triangle. Okay, so if we're going to show our working out clearly for the examiner, then let's go back to where we had the angle 56. What was the next thing we did? We worked out angle OCB. Okay, so angle OCB we worked out to be 35 degrees. Okay, the reason why is because it's isosceles. Because of being an isosceles triangle, therefore it's the same as angle OBC. And the next thing we did is we worked out the angle OCA. OCA we said was 21 degrees. Okay, and the way we got that, we did 56 take away 35, and therefore the last one, angle CAO, was 21 degrees. Again, because of being an isosceles triangle. Okay, so that's the answer to the first question that we're doing today. Question number 12. Answer is 21 degrees. Okay, any questions on that before we move on? Okay, if not, let's go to question number 13. Okay, so we've got two shapes here. Describe fully the single transformation that maps triangle A onto triangle B. Now, this is worth 2 marks. So the different transformations that we have, it could be rotation, reflection, translation, or enlargement. It's going to be one of those 4. Now straight away, because you can see the shape's gone smaller, okay, this transformation will be an enlargement. Okay, now remember, when we're describing an enlargement, there's 2 or 3 extra pieces of information we need to give. We need to give the center of enlargement and the scale factor. Okay, so the first thing we need to state that this is an enlargement. We need to work out the scale factor, and we need to work out the center of enlargement as well. So first of all, the shape's gone smaller, hasn't it? So therefore we know that the scale factor is going to be a fraction. Okay. Second of all, you can see that it's not. It's kind of flipped as well, hasn't it? So therefore we know it's going to be a negative scale factor. So it's not only going to be a fraction, it's also going to be a negative scale factor. Let's see first of all by how much times has it gone smaller. So if we just take one length here, so that's 3 squares long, 1 square long. So it's gone a third of the size. And let's just double check with this last length. Okay, it's gone from 6 wide to being 2 wide. So yeah, again, so the scale factor is definitely a third. It's gone 3 times smaller, and because it's kind of inverted itself, okay, we know that the scale factor has to be a negative. Okay, just remember that, because if it was just if the shape had only gone 3 times smaller, then it would just look like this, a little bit like that. But because you can see it's been inverted, remember that it's going to be a negative scale factor. Okay, so that's that. Next thing we need to write down is the center of enlargement. Okay, a couple of ways you can do this. The way I like to do it is I look at each point and I line them up with the corresponding points. So this point here joins up here, Okay, this point here is going to join up with the one here, so just join them all up with the ruler as best as you can. Try again. Okay, and then the last one joins up roughly around here. Okay, now mine's not that accurate. When you do it with a pencil and a ruler, you'll get a more accurate answer. But okay, this is actually, it's not very clear because for some reason it's not drawing the line properly. But with the points where all three lines intersect, that's the center of enlargement. Okay, so the center of enlargement here is the coordinate 2, 2. Okay, this question's worth 2 marks. Okay, let's go on. Question 14. Okay, indices. So we've got 16 over 81 to the power of 3 over 4. Now with indices, when you have a fractional indice, remember that the denominator tells you the root, okay, what root to find, and the numerator tells you what power to raise it to. So what this means 16 over 81, we need to find the fourth root of it. So I'm going to find the fourth root and then raise it all to the power of 3. Okay, so the fourth 16, so the fourth root of 16 is 2, because 2 times 2 times 2 times 2 is 16, and the fourth root of 81 is 3, okay, because 3 times 3 times 3 times 3 is 81, so that becomes 2 over 3, 2/3. We're going to raise that all to the power of 3. 2 cubed is 8, and 3 cubed is 27. So your answer is 8 over 27, 2 marks there. Part B, we've been given 3 to the power of A is a ninth, 3 to the power of B is 9 root 3, and 3 to the power of C is 1 over root 3. Work out the value of A at B at C. First one, 3 to the power of something equals 1 over 9. Okay, now anytime when you have an indice, if it's a negative, for example 2 to the power of minus 2, the negative tells you to find the inverse of it, to flip it. So instead of being 2 over 1, it becomes 1 over 2, and then that 2 tells you to square it, so that'll become 1 over 4. Same thing that's happened here. So A is the power of minus 2. Okay, so when you do that, 3 with a negative power becomes 1 over 3, then that 2 tells you to square all of it, so it becomes 1 over 9. So A equals minus 2. The next one, we've got 3 to the power of B equals 9 multiplied by root 3. Okay, now I'm going to break this down. So we've got 9 times by root 3. Okay, 9 is basically 3 squared multiplied by, and root 3 is 3 to the power of half. So if you add those two up, remember the laws of indice, just if the base numbers are the same, you can add the powers. 2 add a half becomes 3 to the power of 2.5. So B is 2.5, 2.5. The last one, 3 to the power of C is 1 over root 3. So if you have 1 over root 3, so we start with 3, we can see it's inversed, it's flipped like we said earlier, so we know it's going to be a negative. And because you're finding the square root of it, Okay, you know that's going to be a half. So therefore C equals minus a half, minus 0.5. So the value of A plus B plus C is going to be minus 2, add 2.5 and minus 0.5. Okay, which equals 0. So work out the value of A plus B plus C. The answer is 0. Okay, and that's worth 4 marks. Altogether, 2 marks for part B. Okay, any questions on that one? Okay, let's move on. Question number 15. So here we got 3 solid shapes, A, B and C are similar. The surface area of shape A is 4 centimeters squared. The surface area of shape B is 25 centimeters squared. We're told that the ratio of the volume of shape B to the volume of shape C is 27 to 64. Question's asking us to work out the ratio of the height of shape A to the height of shape C. Give your answer in its simplest form. Now let's look at the first bit. We're told that the surface area of shape A is 4 centimeters squared and B is 25 centimeters squared. So the ratio of A to B, we're told, is 4 to 25. So if we want to work out one length of this, because we're working with surface area, you have to square root both sides. Okay, because when you have two shapes which are similar, and if we're given that the area of one, let's do a simple example. If we look at a square that's 1 by 1, the area is 1 centimeter squared. Now if we have another square that's say 2 by 2, the area is 4 centimeters squared. Now what's happened to the area? How many times bigger has it gotten? Now although the shape has only gone 2 times bigger, so each length has gone 2 times bigger, hasn't it? But the area has gotten 2 squared times bigger. Okay, just remember that. Whenever you want to work out a similar shape's area, always square the scale factor. And with volume, you have to cube the scale factor. So if we're doing the inverse, square root it. So therefore the ratio of one length is going to be 2 to 5. Okay, that's the ratio of A to B. Then we're told that the ratio of the volume of B to C is 27 to 64. Now if you want to work out one length, opposite of cubing is cube root. So cube root of 27 is 3. Cube root of 64 is 4. Okay, so we've got two ratios here. We've got A to B and B to C. Now both have a common B in it. If we want to compare the ratio altogether, to compare A to B to C, we need to make the B's equal. Okay, now we can make them equal by multiplying this ratio by 3 and multiplying this ratio by 5, and by doing that we get a common value for B of being 15. So multiply this ratio by 3, you get 6 to 15, and here we get 15 to 20. So therefore the ratio of A to B to C is going to be 6 to 15 to 20. It asks us to give our answer in its simplest form. So this ratio, 6 to 15 to 20, if we simplify that, we can divide each one by 2, and also we just want the ratio of A to C. So the ratio of A to C is going to be 6 to 20. In its simplest form, can divide both by 2, so you get 3 to 10. That's your final answer, 3 to 10. Okay, question 16. Prove algebraically that 0.256, okay, with the 5 and the 6 recurring, can be written as 127 over 495. So we know that we can write down that x equals 0.256, and because it's only the 5 and the 6 recurring, it looks like this: 5 6 5 6 5 6. Okay, now with a question like this, what we want to do, we want to eliminate the recurring values. So we want to eliminate the 5 6 5 6 5 6. So let's times everything by 10 first. So 10x would become 2.56 5 6 5 6. Okay, but these don't line up. Starts with a 2 here, this starts with a 5. So if I times it by 100, if I times x by 100, I'll get 25.656565. That's no use. If I times it by 1000, I'll get 25. If I times it by 1000, sorry, I'll get 256.5656, and therefore that will line up the two recurring values. So watch, if I times it by 1000, we get 256.565656. Now I'm going to call this one, I'm going to call this the first equation, I'm going to call this the second equation. Now to eliminate those recurring values, we're going to do equation 2 minus equation 1. So we get 1000x take away 10x is 990x. 256, well, the recurrings, these basically cancel out, don't they? So we're just left with 256 take away 2, which is 254. Solve this equation, divide both sides by 990, so you get x equals 254 divided by 990. Question says that prove that it can be written as 127 over 495. Well, yeah, because we can divide both these by 2, cancel that down. By dividing by 2, you'll get 127, and half of 990 is 445. Okay, that's it. Okay, so we've shown and we've proven algebraically that it can be written as 127 over 445. Okay, everyone okay with that one? Number 17. Okay, so it's questions on transformation of graphs. We're given that this is a sketch of a curve. Okay, rather no, this is not a transformation. This is working the coordinates of the turning point. Okay, the transformation comes in question 18. Alright, so the equation of the curve is y equals x squared at ax plus b, where a and b are integers. The point 0, minus 5 and 5, 0 lie on the curve. Find the coordinates of the turning point of the curve. Okay, now the turning point, okay, sometimes called the turning point, sometimes called the minimum point. Okay, it's basically the lowest point on the curve. Okay, so that's your turning point here. We're told that the points 0, minus 5, so that's 0, minus 5 is here. 0, minus 5 is this point here, and the coordinate 5 0, which is this one here, are both on the line. To work out the turning point of the parabola, which is the curve, you have to use completing the square. But for this question, we can't just complete the square because we don't know what the equation of the line is. So what we need to do is we need to substitute the values of x and y to find out what the equation of this line is. Okay, so first of all, I'm going to use the first coordinate, 0 and minus 5. So I'm going to use x equals 0 and y equals minus 5 to find the value of b. Okay, so using the equation, So we know that y is minus 5, so it becomes minus 5 equals x squared, which is 0. Add ax is going to be a times 0, which is also going to be 0, plus b. We need to find out what b is. So 0 squared is 0, add 0, which is 0. Then add b, so b equals minus 5. b equals minus 5. Next, now that we know what b is, I'm going to use the fact that x equals 5, y equals 0, and now that we know b is minus 5, we want to use all of that to work out what a is. Okay, so let's write that down clearly so we know what we're doing. So we're going to use x equals 5, we're told y equals 0, and we've just worked out that b is minus 5 to find a. Once we do this, we'll have the full equation of the line. So y is 0, so let's substitute that. We get y is 0 equals ax. Okay, we don't know what that is, we don't know what a is. Okay, but we do know that x is 5. So it's going to be x squared, so 5 squared. Add ax is going to be 5a. Plus b, well b is minus 5, so that becomes minus 5. So therefore 0 equals 25. Add 5a minus 5. So 0 equals 20. 25 minus 5 is 20. Add 5a. So rearrange this. 5a equals minus 20, or you can say minus 20 equals 5a. So therefore a equals minus 4. Okay, so now that we know what my b is, I know what the a is, we can write the equation of this line. So the equation of the line is y equals x squared b was minus 5, wasn't it? So let's have a look. So plus ax, we know a is minus 4, so it's going to be minus 4x plus b, where b was minus 5, so that becomes the equation of the line y equals x squared minus 4x minus 5. Okay, at this point now we're just going to complete the square to find the turning point of this graph. So in order to complete the square, remember, just half the coefficient of x, so we get x minus 2 squared minus 5. But when we expand this bracket, you'll get a positive 4, which you don't want because 2 squared is 4, so you want to subtract that 4. So therefore y equals, let's expand that, you're going to get x minus 2 squared minus 5 minus 4 is minus 9. Okay, so therefore the turning point, remember, because we want the lowest point, we want y to be the smallest possible number. In order for y to be the smallest possible number, we need to make this bracket here equal 0. Okay, but the way we make this bracket equal 0, x has to be positive 2. Okay, when x is positive 2, y is going to be minus 9. So therefore the turning point is going to be the coordinates 2 minus 9. Okay, and that's the answer. So the turning point is 2 minus 9. Okay, is that understood? If you have any questions, you can let me know in the comments below. Okay, let's carry on then. Question number 18. So this question here is on transformation of graphs. Okay, and just as a reminder, when we have transformation of graphs, there can either be a transformation in the y direction or there can be a transformation in the x direction. Okay, this question here, it's asking us to, it's given us the transformation. So it says that y equals f of x minus 2. Okay, let me just get this screen back again. Okay, so part A says that on the grid above, sketch the graph of y equals f of x minus 2. Okay, now, one sec. F of x minus 2, okay, this is going to be a transformation in the x direction. Okay, this one here, so I'll highlight that. This one here. This represents a translation of y of f of x by the vector minus a 0. Okay, which basically means that you go the opposite way. So if that's minus 2, you have to go 2 to the right. Okay, so the graph is going to go 2 units to the right. So this point here from minus 1, this point here, it goes to positive 1. Okay, this point here from 3 is going to go to 5. Okay, and this point here from 1 will go to 3. Okay, so your curve, you want to draw as best as you can. Okay, not like that. Let's try this way. Okay, you get the idea. You want to do better than me. You basically want to take it 2 places to the right. Okay, so that's your answer there. Next part, it says that on the grid, graph A, which is this one here, has been reflected to give graph B. Write down the equation of graph B. Now, here this is a reflection, isn't it? Okay, this is a reflection in the y-axis. Okay, and the way we show that, okay, is basically y g negative x. Okay, so that represents a reflection in the y-axis. Okay, so 1 mark each. Okay, and that was the one, number 6 at the bottom. This represents a reflection in the y-axis. Okay, which is similar to number 5. It's just a scale factor of minus 1 in the x direction. Okay, so that question there was on transformation of graphs. Let's go down to question number 19. Okay, so here we're told that for all values of x, we've given that f of x equals x plus 1 all squared, and g of x equals 2 brackets x minus 1. So we've got two functions here. Show that the g of f of x is 2x bracket x plus 2. Now, what does that mean? Okay, all that simply means is substitute f of x into g of x. Okay, so that's just another fancy way of just saying that substitute f of x into g of x. Okay, so let's do that then. So we've got the g of x, we're told is 2 bracket x minus 1. So when x is x plus 1 squared, just substitute x plus 1 squared into x. So we're going to have to use double brackets. So when x is x plus 1 squared, that take away 1. Okay, this is what we're dealing with. So let's expand the x plus 1 squared. So we're going to get 2 bracket x plus 1 all squared is going to give you x squared, add 2x, add 1. So that's that expanded, and then take away 1, which is that bit there. Okay, so what does that give us if we simplify that down a bit more? leave that for now. X squared add 2x, and then positive 1 take away 1 is just 0. So that's it. Okay, this is telling us to show it in this form. Okay, which is easy. All we need to do, we've got an x squared and we have x here. We can factorize that by taking out a common x. So that becomes 2x bracket x plus 2. Okay, and that's the answer here for 2 marks. Okay, we've shown that 2x bracket x plus 2. Okay, part B, it says find g to the negative 1 when x is 7. Okay, all that means is that find the inverse of the function g when x is 7. Okay, so first of all, we know that g of x, what's the g of x? We're told that, change the highlighter, get a pen back, g of x is 2 bracket x minus 1. We're told that in the question, 2 bracket x minus 1. Okay, so if we expand that, what do we get? G of x equals 2x minus 2. So if you want to find the inverse of that, it basically means we want to do the opposite. Okay, now there's 2 ways that we can find the inverse of this. Okay, so here we're told that you get x, times it by 2, and then subtract 2. Now what's the opposite of that? Well, instead of subtracting 2, we can first write down the inverse of x. Instead of subtracting 2, we can start with x, we can add 2, and instead of multiplying by 2, the opposite of that is dividing by 2. So the inverse of the function g is basically x plus 2 all over 2. Now that's one way you could have done it. Now another way you could get the inverse, okay, I'll show you here. Or if we make this y equals 2x minus 2, so using the same one here again, 2x minus 2, we can inverse it by switching the y with the x, so that will give us x equals 2y minus 2. And now rearrange this then to make y the subject. You'll get opposite of minus 2, add 2, x add 2 equals 2y. So therefore y equals x add 2 all divided by 2 equals y. Either way you do it, okay, you get the same answer. Okay, so that's the inverse of the function of g. So when x equals 7, okay, so just substitute now. When x is 7, okay, we're just going to substitute that into that expression there. So when x is 7, you're going to get 7 add 2 divided by 2, which is 9 divided by 2, which is 4.5. That's your answer. So find the inverse of the function of g when x is 7. The answer is 4.5. Everyone okay with that one? Let's turn over. About 3 more questions left. Question 20. Next. So here, okay, we've got surds. Show that root 18 add root 2 all squared divided by root 8 to take away 2 can be written in the form that where a and b are integers. Okay. Now this question is going to have quite a few steps in there. The first thing we need to do, we need to simplify these surds. Then we're going to have to rationalize the denominator, and there'll be a bit of factorizing in there at the end as well. Okay. Now on the side, we'll just go through it. I'll show some of the working on the side, and then I'll do the main working in the center. But just to show you where I'm going to get my numbers from, first thing first, we need to work out, or we need to simplify root 18. Okay, and when we're simplifying surds, remember you want to find 2 factors, one of which being a square number. So root 18, that's the same as doing root 9 times by root 2, which becomes 3 root 2. Okay, that's first thing. We're going to need that for this one here. Root 8, let's simplify that. Root 8, that's the same as saying 4 times 2, isn't it? Root 4 times root 2, which simplifies down to 2 root 2. Okay, so that's just a side point, so let's get into the question here then. So let's simplify the first bit. So we know that root 18, that simplifies down to 3 root 2. Add, we get that root 2 here, let's write that down. All of this squared divided by root 8, we've worked that out here, that simplifies down to 2 root 2. Take away 2. Okay. Next, 3 root 2 add 1 root 2. That's basically saying, think of it like this, 3x add 1x gives you 4x, isn't it? Same thing here. Because we don't know what root 2 is, it's an unknown. 3 root 2 add 1 root 2, we're going to have 4 root 2's. So 4 root 2 all squared divided by 2 root 2 minus 2, that stays the same. Okay. What about this? How do we expand that then? Well, just this bit here, 4 root 2 all squared. Okay, I'll do that here as well. So 4 root 2 all squared, that basically means, so if I just write down here, 4 root 2 all squared basically means 4 times root 2 times by itself 4 times root 2. Well, 4 times 4 is 16, multiplied by root 2 times root 2 is 2. 16 times 2 is 32. Okay, so the numerator here, 4 root 2 all squared, that simplifies down to just 32. Divide all that by 2 root 2 minus 2. Okay, so we've done the simplifying now. That's done. Minus 2. Now we need to rationalize the denominator. Okay, how do we rationalize the denominator? We need to multiply by 2 root 2 plus 2. Okay, and by doing that, we'll rationalize the denominator, meaning we'll get rid of the surds. So I'm going to write down 32 over 2 root 2 minus 2. You want to multiply this by 2 root 2 add 2 over 2 root 2 add 2. Okay, let's look at that then. Again, I'll do some more working out just on the side, just to keep it a bit separate. So let's do the numerators first. We want to do 32 multiplied by 2 root 2 add 2. So 32 multiplied by 2 root 2, can do a bit better than that. 32 multiplied by 2 root 2 add 2, close brackets. So let's do 32 multiplied by 2 root 2 first. You're going to get 64 root 2 add, then 32 times 2 is just 64 again. Okay, so scroll down a little bit. That's the numerator. Okay, what about the denominator? I'll do that as well before I show my work, before I write it down. So we're going to have, we've got 2 root 2 minus 2 multiplied by 2 root 2 add 2. Okay, now I always recommend my students that they use the grid method when they're multiplying out. Okay, especially when you have surds as well. It just means that you're less prone to make mistakes. So we want to do 2 root 2 and we have a minus 2 in the first one, multiplied by 2 root 2 again, 2 root 2 and a plus 2 here. Okay, let's put the grid on it as best as we can. Okay, and we're multiplying, isn't it? So 2 root 2 times 2 root 2. Well, let's look at the number here first. 2 times 2 is 4, and then root 2 times root 2 is 2 So 4 times 2 is 8. And then minus 2 multiplied by 2 root 2 is going to be minus 4 root 2. And this one's going to be positive 4 root 2. And then 2 multiplied by negative 2 is minus 4. So what does that give us? That gives us 8. Well, the minus 4 root 2 and the plus 4, those two will cancel out. We're just left with 8 take away 4, which is just 4. So the numerator, when you multiply these two, is going to give us 64 root 2. Add 64 all over 4. Okay, because the denominator is just multiply it to give me 4. Divide this by 4. 64 root 2 divided by 4. Again, that's like saying 64x divided by 4. Okay, you can do that. There's just 16 root 2. Add, and 64 divided by 4 is just 16. Okay, so we've got 16 root 2, add 16. Let's go back. Is that the answer? Well, no, because it wants it in this form here, so we need to factorize it. Okay, so we need to factorize this by taking out a common 16, which is in both. So we get 16 bracket root 2 add 1. Okay, so we've got 16 bracket root 2 add 1. It wants it in this form here. It wants b, the number, in front of root 2. So let's just do it exactly as it wants. So it's going to become, again, 16 bracket 1 add root 2. Okay, and that's your final answer. 16 bracket 1 add root 2. 3 marks. Okay, I think they could have given an extra mark on that one, but nonetheless, that's worth 3 marks there. Okay, any questions on that one? Okay, next one, question 21. Okay, we've got 2 more questions. Here, we've got OAB is a triangle. We're told that OPM and APN are straight lines. M is the midpoint of this line AB. We're given that OA is A, so I'll write that down here. And we're told that O to B is B. Next piece of information, the ratio of OP to PM is 3 to 2. Okay, so straight away we know that O to P, this is going to be 3/5 of the line, and this is going to be 2/5 of the line. I'll just add that for now. Okay, maybe a bit bigger. So 3/5. OP is 3/5 and PM is going to be 2/5. Work out the ratio ON to NB. How many marks is this? This is worth 5 marks. Okay. Prepare yourselves. Okay, it's probably one of the harder questions on vectors of sin in a long time. Okay, so let's go through it carefully. Now, this question is going to have numerous steps in there. Okay, we're going to have to be working out quite a lot of different vectors. Now, essentially, what it's going to boil down to is we're going to work out we want to work out the vector AN. Okay, that's kind of what we're aiming for. Okay, we want to work out the vector AN. Now, for now, I'll just keep it that. We want to work out. Let's try to work out the vector AN. Okay, and that's going to help us with the final answer. Okay, so first things first. Then let's see what kind of vectors can we make. Okay, based on this. Okay, so we already know that O to A is A. We know O to B is B. Well, we can work out A, B if that's the case. Okay, we can work out vector AB. So if I start by working out vector A. Okay, I want to write as neat as I can. A to B. is going to be AO add OB. So that's going to be minus A add B. Okay, now that we know AB, which is this line here, we know that vector now, AB, well, we can now work out AM as well, okay, because we're told that M is the midpoint. So AM is going to be half of AB, and we know that AB is minus A plus B, so it's going to be half of AB, which is minus A at B. Okay, so far so good. We know what AM is. Can we work out the vector OM? Well, yeah, we can, because we know what OA is, and now that we know what AM is, we can work out the vector OM as well. So OM. I'll just write down now the journeys I'll be taking. So OM, we're going to go OA first. And in exam, it's very useful to do this, okay? Always write down exactly which vectors you're working out and add AM. So OA is going to be positive A. Add AM, that's M here. AM was this one here, a half of minus A plus B. Simplify that. So that's going to be A add, well, it's going to be A minus a half of A, because a half times minus A is minus a half of A, so that's a half of A. Add a half times B is going to be a half of a B as well. Okay, so we know what OM is. We know this vector now, OM. Okay, can we work out OP now? Yes, we can. Okay, we can work out what OP is, because it's just going to be 3/5 of OM. Okay, so OP, let's have a go at that one next. OP this is going to be, I'll write down exactly what we're doing. We want to work out 3/5 of OM. We know OM is half A at half B, so that's going to become 3/5 of a half of A at a half of B. Okay, let's work that out. So we're going to multiply it, yeah? So 3/5 of half of A is going to be 3/10 of A. Add 3/10 of B. Okay, that's done. So now that we know what OP is, OP, can we work out AP now? If we know what OP is, well, we can get AP now by going AO and then OP. Okay, so let's work out AP. So let's write down the journey we'll be taking. We're going to go on AO first, and then add OP. AO is going to be minus A. Add OP, we just worked out here, is 3/10 of A. Add 3/10 of B. Simplify that. Okay, so we got a minus 1A, add 3/10 of A. So we got minus 1, add 3/10. Okay, and minus 1, you can think of that as a minus 10/10. That's a whole, isn't it? Minus 10/10. Add 3/10. Minus 10 add 3 is minus 7, isn't it? So that's the same as saying minus 7/10 of A. Add 3/10 of B. Okay, well, now that we know what AP is, okay, this is going to be important, so I'm going to highlight this one for now. So we know what AP is. Okay, let's go up here. So we know that AP, we've worked out the vector here, minus 7/10 A at 3/10 B. Now AN, this is an important one now. Okay, so if we know that AP, now look at the whole line AN. P is a point on the line AN, isn't it? So AP, this is some kind of fraction, yeah, it's some kind of fraction of the full line AN. Do you all agree with that? So if I want to work out AN is going to be some multiple of AP. Now I can write that as follows. So AN, I'm going to write it up here. Oh, not the highlighter again. I'll use a different color now. So AN the vector AN, it's basically the full line is some multiple of AP, isn't it? What that multiple is, I don't know, so I'm going to call it X. So something multiplied by the vector of AP gives me the answer to AN. Well, we just worked out the vector AP, didn't we? Here the one that I've highlighted is minus 7/10 A add 3/10 B. So I can write that like this. So X multiplied by the vector AP, which was minus 7/10 of A at 3/10 of B. Okay, let's expand that bracket. You're going to get minus 7/10 of AX add 3/10 of BX. Okay, this is important, so I'll highlight this for now as well. Okay, now let's look at this carefully. So we got vector AN. I've just given you one way that we could have got the vector AN, and that was some multiple of AP. Now there's another way that we could also get the vector AN, and that would be to go down AO and then add ON. Okay, now similar kind of thinking. Now we don't know what ON is, but we do know that OB is B. So ON is going to be some fraction of the vector OB. Does everybody agree with that? That ON is going to be some fraction of the full vector of OB. So let's now show an alternative way that we can get the vector of AN. So or vector AN we can get AO add ON, this bit here, ON. Well, AO is easy. We know the vector AO is going to be minus A add. Now this is what I was talking about earlier. So we know that ON is going to be some fraction of the full line, which is B. Now I don't know what that fraction is. I don't know what fraction that's going to be. So let's give it a different letter. So we call the first one X. Let's call this one Y. So I'm going to call this add YB. Oops. Add YB. That'll do. Okay, so we know that the full vector O to B is B. So O to N is some factor, okay, some fraction of B. Now, so basically what we've just done now, we've got two vectors. Okay, we've represented the vector of A to N in two different ways, and they both must be equal. Okay, so this one here has to be equal to this one here. Okay, we've got two vectors for A, N. Now let's compare them both then. Let's compare them both separately. So if we look at the A's first of all, use a different color. Let's look at the a's to begin with. So here we had minus 7/10 ax, and this is just minus a. So therefore, they both have to be equal. So we can show that like this: that minus 7/10 of ax is equal to minus a. Let's see if we can work out the value of x. So we can eliminate the a's, divide both sides by a. So we're going to get minus 7/10 of x equals minus 1, because minus a divided by a is going to be minus 1. So this is basically, again, we're kind of working out if minus 7/10 of x equals minus 1. Okay, so work out what x is. So basically the inverse. So therefore x equals, okay, you can do it in steps as well. So we can do, so here we're multiplying by negative 7/10. So when it goes over to this side, it'll become minus 1 divided by negative 7/10. And the way we divide by a fraction, keep the first one as it is. So minus 1, change it, becomes 10 over negative 7. So that becomes minus 1 times 10 minus 10 divided by negative 7. Okay, and then because we're both negative, it's the same as saying 10 over 7. Okay, so therefore x equals 10 over 7. Okay, so we've worked out what x is. Okay, I'll highlight that in a different color. X equals 10/7. Next, let's look at the b's. Let's compare the two b's together. So in the first one we had 3/10 b, and in the second one is yb. So we can write that down like this: 3/10 bx is the same as yb. Same process, let's solve this. So we can divide both sides by b. We know what x is, don't we? We know what x is. X is 10 over 7. So the b's, they'll cancel out. So we get 3/10. The b's no longer exist. The x is 10 over 7. And this will give us our y value. So the 10 and the 10 cancel out. So therefore, y equals 3 over 7. Nearly there. So we're told that y equals, we can work out now that y is 3/7. Therefore, let me get rid of this working out now. Now, remember what we said earlier, that the vector O to n is going to be 3/7 of b. That's what we just worked out, isn't it? Look, so vector O to n, we said was yb. We know that y is 3/7. So let me write it down here. So the vector O to n is 3/7 of b. So we know that from O to n here, this is going to be 3/7. Okay, and what about n to b? What's that then? It's going to be 4/7, isn't it? So therefore, the ratio of ON to NB is 3 to 4. That's your answer. The ratio of O to N, from the vector O to N to NB is 3 to 4. Okay, that was a tricky question. Okay, I think the hardest part is this stage here, when we wanted to work out the vector AN, okay, to identify that it's some kind of multiple of AP, and then finding the alternative way of getting it as well, making those two equal to work out the value of the x and the y, then bringing that all back together again. Okay, so have a think about that question. Okay, if you have any further problems, if you have any questions, okay, feel free to leave any comments. Otherwise, we'll do the last question of the paper. Okay, I'll just write down the answer on the line here, 3 to 4. Okay, last question of the paper, question 22. There are only green pens and blue pens in a box. There are 3 more blue pens than green pens in the box. There are more than 12 pens in the box. Simon is going to take at random 2 pens from the box. The probability that Simon will take 2 pens of the same color is 27 over 55. Work out the number of green pens in the box. Okay. First thing, let's think about how many pens there were. So we're told that there's only green and blue. There are 3 more blue pens than green pens. So how many blue pens are there? Well, we're gonna write it algebraically. So how many blue pens? Well, there's 3 more blue pens than green pens. So 3 plus. If I make the green pens G, therefore the blue pens are 3 plus G. Green pens, there's G green pens. In total, how many pens are there? 3 add G, which is basically 3 add 2G. Okay, that's gonna help us. So we know that in total there's 3 plus 2G pens. I'll try to do this on a tree diagram. So he's taken 2 pens at random, right? So it's either going to be green or blue, the first pick, and then the second pick again, it's either going to be green or blue for both options. Green and blue. Okay, now what's the probability of taking out a green pen? Well, how many green pens were there? I'll use a different color. There was G number of green pens, so it's going to be G over, in total how many pens were there? 3 plus 2G plus 2G. So the probability of getting a green in the first pick is G over 3 plus 2G. The probability of getting a blue in the first pick, well, there's 3 plus G blue pens, so 3 plus G blue pens out of a total 3 plus 2G. Okay, I hope you can read this. 3 plus 2G, that's a G here. Okay, that's the first pick done. Second pick. Now the question doesn't say explicitly, but you have to understand it from the question. He's going to take at random 2 pens from the box, so there's no replacement here. Okay, he's going to take it out. So if the first pen he took was a green pen, then there's 1 less green pen in the box, isn't there? So this is the probability of getting a second green pen is going to be G minus 1 divided by, and now the total number of pens in the box has also gone down by 1 as well. So that's going to be 3 take away 1 is going to be 2. Instead of 3 plus 2G, it's going to be 2 plus 2G. Okay. Okay, so that's that one. Now the question tells us that that we're told the probability that he'll take 2 pens of the same color, so it's going to be a green and a green, or it's going to be a blue and a blue. I don't need to work out the probability of getting a second pen blue here. And following this one, again, we just need to work out the probability that the second pen is also a blue. So if there was 3 plus G blue pens to start with, if there's going to be 1 less now, so it's going to be 2 plus G over, again there's 1 less pen in the total box now, so it's also going to be 2 plus 2G. Okay, what's the probability of getting a green and a green? So the probability of getting a green and a green. Okay, we're going to be dealing with algebraic fractions now, so we're going to be multiplying them. So we've got g over 3 plus 2g multiplied by g minus 1 divided by 2 plus 2g. Okay, when you multiply those out, we're going to get g squared minus g squared minus g all over 4g squared. So yeah, expand, so multiply these two out, so we get 4g squared, add 10g, add 6, add 10g, add 6. So the probability of getting a green and a green is this. The probability of getting a blue and a blue, let's do that next. The probability of getting a blue and a blue, we're going to multiply these two fractions together, so that's 3 add g divided by 3 add 2g. Multiply that by this. 2 add g divided by 2 plus 2g. Multiply those together, we get g times g is g squared. Add 5g, add 3 times 2 is 6, all over, and the denominator is going to be the same, isn't it? So that's 4g squared, add 10g, add 6. Okay, with the probability that Simon will take 2 pens of the same color, so that's going to be, he's either going to take out a green and a green or a blue and a blue, is 27 or 55. So now what we need to do, we need to basically add this fraction here with this fraction here, okay, and that would be the probability of getting 2 of the same color. Okay, so let's write that down. So the probability of getting the same, let's get red. So the probability that he gets the same color is going to be that fraction here of getting a green and a green, add that fraction here. So that's g squared minus g because they're both the same denominator. I'm just going to go ahead and add it here on top of the on the numerator. Add g squared, add 5g, add 6, all over 4g squared, add 10g, 4g squared, add 10g, add 6. And the question tells us that the probability of getting the same color is 27 over 55. So this is going to equal 27 over 55. Let's simplify this. So we got g squared, add a g squared. That's 2g squared. 5g take away 1g is a positive 4g. Add 6, all over 4g squared, add 10g, add 6 equals 27 over 55. Now obviously because we've got two equal fractions, we're going to cross multiply, isn't it? So we have to multiply this, the numerator, by 55 and multiply the denominator by 27. But I'm going to simplify this fraction down by dividing everything by 2. So divide by 2 here, make things a bit simpler. So divide the whole thing by 2, we're going to get g squared. Okay, I'm running out of space here. Shall we go over to this side here? Let's go over to this side. So divide everything by 2, we're going to get g squared plus 2g plus 3 all over 2g squared excuse me, 2g squared add 5g add 3, this all equals 27 over 55. Now let's cross multiply. So we're going to get 55 multiplied by g squared add 2g add 3 equals 27 multiplied by 2g squared let me just try going across. Okay, that's better. 2g squared, where were we? 27 multiplied 2g squared add 5g add 3. Let's expand both sides, so we're going to get 55g squared add 110g add 165 equals, expand this side here, 54g squared add, and 27 times 5g, 135g add 27 times 3 is 81. Just about make it fit there. Let's rearrange all this then. So we got a positive 54g squared here, take that over to that side, it becomes minus 54g squared, so we're left with just 1g squared. 110g minus 135g minus becomes minus 25g. Then 165 take away 81, it's going to be positive 84. So that now equals 0. Factorize this. Okay, so two numbers that multiply to give me 84 and they add up to give me 25. So now they're both going to have, first of all, a g in there, there, and there. Okay, so the two numbers are 4 and 21. So 4 times 21 is 84, and they both add up to give me 25. Okay, and because that's negative, I know they're both going to be minus here, minus there. So therefore, the green g equals 4 or 21. So now there's either 4 green or there's 21 green. Which one is it? They're both positive. Let's go up. Let's go read the question. There's one piece of information that we've not used yet, and that's this one here, that there are more than 12 pens in the box. So if you make the green to be 4, so green would be 4, and then blue would be 3 at 4. So if, let's write down, let's just go through this fully. So if green equals 4, then blue would be 3 at 4, which is 7, and that gives you a total of 11 pens, isn't it? What does the question say? There are more than 12 pens in the box, so green definitely can't be 4. If we use either one though, if green is 21, if green is 21, then blue is going to be 3 at 21, which is 24. Then the total would be 45 pens. Okay, and there are more than 12 pens in the box, so that works then. So therefore, work out the number of green pens in the box. G, yeah, is 21. So I'm going to use this as an answer, that the number of green pens in the box is 21 green pens. And that completes this question. Okay, that's worth 6 marks there. Okay, quite a lot involved in that question. So it's not only working out probability tree diagrams, we have to use algebra as well to form the expressions. Okay, algebraic equations. Okay, factorizing. Okay, and then just a bit of reasoning. Okay, at the end as well to work out which one it was. Okay, guys, thanks Cam for tuning in. Everybody else as well. If there's any further questions, okay, please you can let me know. Next week I'll be doing another one, most likely foundation. So I've completed now the higher paper 1. I'll probably do a foundation next, and then we'll look at paper 2 and 3 as well. Okay, yeah, just have a look at my Facebook page to keep up to date with when I'll be doing those. And thanks a lot for tuning in, guys. Okay, hope to see you all soon.